Welcome back, ladies and gentlemen. Today we're going to take care of section 5.5, Triangle Inequalities. Up on the screen, as usual, you'll see your exit question for the day. We'll start off with the two theorems. Actually, there's three theorems in this section, but two theorems that go together, and they have probably some of the most awkward phrasing in the book, but if you read through those, here's the gist of it. If you have a triangle, the largest angle always opposes the largest side, and the smallest angle always opposes the smallest side. And given that a triangle has three sides, let's not forget about the medium side. The medium angle will oppose the medium side. So we can ask you to do a couple questions that are quite simple. I've made the right one basically as difficult as it could be phrased. Why don't you pause the video and see if you can figure these out. Okay, the only real trick to these is making sure that we use good notation. So that's basically the only mistake I ever see on the tests. And on this particular triangle, we got to find the missing angle, which is 40 degrees. And then from there, it's just a matter of putting things in order. So this is the smallest angle. So opposing that, segment AB should be the smallest. This is the medium angle. So that's the next biggest side right there, BC. And then this is the largest angle, so the side opposing it should be the longest side. So just put those in order using proper notation and following the directions. Over on this side, this one is drawn not to scale, obviously. So that's part of the trick. And the other trick is that one of the numbers was expressed in an unfriendly manner. So if you type that into your calculator, you get that this square root is equal to 165.015, and it's irrational and it keeps going forever. But that's the first three digits of it. And then you'll notice that, well, obviously this isn't drawn to scale because this distance is the longest distance, yet it appears to be the shortest. So we just have to put things in order. So this is the shortest side, so that's going to be the smallest angle. This is the next biggest side, so that's going to be the medium angle. And this is the largest side, so angle D will be the largest. And just writing that down, using commas, using the correct notation, that's all you got to do. The next theorem is the big one for the day, which is the triangle inequality theorem. And it comes from basically this idea right here. So say I give you some sticks of various lengths. Sometimes it's possible to make a triangle out of those sticks, and sometimes it's not. So if I give you sticks of length of like 5 inches, 4 inches, and 2 inches, it is possible to create a triangle out of that because the longest side is not long enough to completely separate the two smaller sides. So in other words, 2 plus 4 is bigger than 5, so if you were to try to construct it, they would actually meet. Whereas if I gave you 3 sticks that were 2, 2, and 5, well, 2 plus 2 is only 4, and it wouldn't quite reach all the way across 5. And then the other thing that's in this theorem is that these are strictly greater than inequalities, and this is showing you why, because if you had a long side of 5 and then the other two sticks were 2 and 3, they would touch each other, but they would fold flat and it wouldn't be a triangle anymore. The big thing that you need to get out of this theorem is being able to write these three inequalities. Okay, so this theorem gives you 3 inequalities, and you have to be able to write them, and it basically works out like you have to use every combination of each side to be greater than one of the other sides. So you'll notice on the right hand side of the inequality, the segments just alternate. We have the green segment, the red segment, and the blue segment. And then the other side of the inequality in each case is just the sum of the other two sides. So basically the triangle inequality theorem says any two sides of a triangle added together have to be bigger than the third side in order for the triangle to work. So any two sides of a triangle must be bigger than the third. So I can ask you questions like this. A triangle has a side lengths of 10 centimeters, 14 centimeters, and an unknown length. First, I want you to pause the video and see if you can write those 3 inequalities that we were just talking about. And then secondly, I want you to see if you can narrow down the possible values of x so that you can still make a triangle out of the deal. Okay, to get the 3 inequalities, you basically set one side of the inequality equal to, or well, not equal to, but put one side of the triangle on the right hand side of the inequality, and then the left hand side is just the sum of the other two sides. So we got 10 plus 4, 14 is greater than x. We got 10 plus x is greater than 14, and 14 plus x is greater than 10. And then from there, you have three inequalities. And the tricky part here to figure out what the possible values of x would be is that you have to kind of stitch these inequalities together. So basically you have to solve all three of them. So what you need to keep in mind when you do this is that in order for this triangle to work, in order for x to be valid, all three of these inequalities must be true for any value of x or any value of x that you specify. So all three have to be true. Not 2 out of 3, not 1 out of 3. All three of them have to remain true in order for your solutions of x to be valid. The second thing you might see is this last one right here, in that you have 14 plus x must be greater than 10. Well, that's kind of special because that's always true. 14 is already bigger than 10, and if you add anything to it, it's going to be bigger than 10. Okay, so from there, solve the remaining two like that. And then you have to stitch them together. So this one says that 24 is bigger than x, or x is less than 24, and this one says that x is bigger than 4. So you need to either write that out in words, or this would be an acceptable answer, this last line right here, or a compound inequality where you list 4 is less than x, which is less than 24. Our next problem is a little bit more complicated, but pretty much the same thing. So why don't you pause the video here and see if you can write those three inequalities and then determine the possible values of x. First step is to write those three inequalities. So instead of just a simple variable this time, now we have a variable expression, but we still make those three combinations. The two sides added together are bigger than the third side, and we do that with all three combinations. Then we solve each one of those inequalities individually, and then we have to stitch together the information. So we have to figure out the values of x for which all three of these inequalities hold. And some of you are good at this. Some of you are just going to be able to pop up and say, okay, x has to be less than 2, but bigger than -1 and bigger than 0.5. So the -1 doesn't really mean anything. This tightens up the range either way. So some of you are just going to be able to look at those three inequalities and stitch them together and say that x has to be between 0.5 and 2. Another way to figure this out is to actually do a quick little number line graph of all three inequalities, and I'll show you how that looks. First, graph a number line, put your numbers on that you got in your inequalities, and then graph each inequality separately. So this one says that x is less than 2, so that would look like open circle there, and from 2 down to -infinity. And then you do that twice more for the green line. That's numbers that are bigger than -1. And then the red inequality, numbers that are bigger than 0.5. And the way you get your solution by looking at this picture is you want to look for the place where all three are true. So we're looking for the triple stack right there. So in this region right here, that's where the triple stack is, that's where the solution is. And then you just have to describe this region with either a compound inequality or with words or whatever. But just do remember, please, that this is a strictly greater than or strictly less than symbol. It does not include the endpoints. That's all we have for the day, so there's your homework assignment, and I'll see you in class.